I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Let me thank all the viewers and subscribers for supporting us. I'm extremely thankful to you, and here is something which I want to share with you. One of our subscribers wrote that this was the only place where he could get solution to his problems, and that too absolutely free. So your donations matter and they change lives. I'd like you to continue doing so. In this series, we are taking up test paper of trigonometry, especially for IB students. That will help all others also. We have 10 questions. In the previous two videos, we have given you a solution for the first 7. Now, we'll take up question number 8, 9, and 10 and provide you with this solution. Here is the formula list which you may need to solve these questions. Normally, a formula sheet is given, but I'll prefer you to remember them. And as you know, in case you want to learn from me, you can always send an email on the address given. Keep supporting us as we provide you absolutely free, useful resource. Now, let's begin with question number 8, which is kind of an identity. It says, simplify within brackets square root 3a sine pi by b whole square plus square root 3a cos pi by b whole square if a and b are non-zero constants. So does that remind you of something? Well, let's rewrite. So we have square root 3, a is a constant, sine pi by b, right, whole square, a and b are constants, plus square root 3a cos of pi by b whole square, right? Interesting way to write. Let me square it. So we get 3a square, and here we get sine square pi by b, plus we get 3a square cos square pi by b, correct? And now if you take 3a square common, what do you get? You get sine square pi by b plus cos square pi by b. Perfect. Which is 1, you know. So this is 3a square, correct? So we have evaluated the expression while simplifying. Now let's move on and take the next question. So I hope you are enjoying this journey of learning. We are almost at the end now. Question number 9 will prove the identity. Sin 2x over 1 plus cos 2x is equal to tan x, which is also equal to 1 minus cos 2x over sin 2x. I have seen this particular identity in every test paper. It may be also a part of solving an equation, right? And therefore, I have rewritten in this way, focus on tan x. So both left side and right side are actually equal to tan x. In an equation, you may be given left or right side with some numbers and you may have to solve the equation. You need to really simplify it to tan x and then do it. So it's very important. Okay, so let's look into this. So we are given sine 2x over 1 plus cos 2x. So let's begin with the left hand side. Let's simplify this. We'll prove this to be tan x. Double angle formula, 2 sin x cos x. And we'll apply the double angle formula for cos 2x also. So better is to write 2 cos square x minus 1. So that plus 1 and minus 1 will cancel, and that is the reason why we wrote this, right? So we get 2 sin x cos x over 2 cos square x. Clearly, we can now cancel one of the cost terms and two also. So what do you get? Well, you get what is expected, which is sin x over cos x, which is tan x. Clear? So simple as that, but very important. And getting this idea, sometimes, writing cos 2x as cos 2 cos square x minus 1 um, may make it difficult to solve. Let's take part B, in which we'll start with the right hand side. In this case, it is 1 minus cos 2x over sin 2x. So 1 minus. So this time we want to cancel 1. So better to write 1 minus 2 sin square x over sin 2x as 2 sin x cos x, right? Just like before, we get sin square x this time in the numerator and 2 sin x cos x in the denominator, cancelling 2's and 1 of the sin x. We are again left with what? Tan x, right? Sin x over cos x, which is tan x. So I hope that is simple, very effective, important formula. Once again, have a look at it. In case you really want to learn and succeed, you may contact me on globalmathinstitute@gmail.com and keep contributing so that we can provide you some brilliant videos free of cost. Now, here is the last question for you. Now, here, the question is to write general solution. So, important thing here is to write a general solution for the given equation. We have kept the equation very simple. Square root of 3 sine secant 2x minus 2 equals to 0. The idea is to understand the concept of how do we write general solution. Is it okay? So then you can extend this to any question. So let's rewrite this. Isolate secant 2x. Secant is 1 over cos, right? So you can write cos 2x, or secant I wanted to write. I wrote sine. So you could write this as cos 2x equals to square root 3 by 2. Makes sense, right? Now that reminds you of a special triangle, right? So let me draw that special triangle for you. Square root 3 over 2, right? I prefer to place it in this fashion. So we see that the related acute angle, I write beta for related acute angle, is pi by 6, square root 3 over 2. Now it is important to understand that cos is actually positive in quadrant 1 and in 4, right? So basically, you have pi by 6 like this, correct? And this is minus pi by 6. So what should be the general solution? So clearly, the general solution will be that 2x is equal to, and the period is 2n pi, right? So 2n pi plus or minus pi by 6. Do you see that? So simple as that. So once you visualize, you understand the process. And now we can divide by 2 and get the value of x, which is 2n pi by 2 plus or minus pi by 12. Or clearly, n pi plus or minus pi by 12. So that is the general solution for x, and where clearly what is n? N belongs to integers. Is that clear to you? So it is important to write n belongs to integers, and so that is how we write a general solution for cosine or secant. So with that, we come to an end of this particular test, which we started off with these questions, as you can see. So we began with simple identities, found the exact values, and solved many questions related, and came to the last 10. I hope you enjoyed this journey of learning, where there was a good review on the formula set and then simple methods of solving these equations. Well, in case you like and subscribe to my videos, that'd be great. And if you want to learn directly, feel free to send an email on the address given. Thanks for your time and all the best.